Hello, welcome to lecture 30. This is James, and let's begin the work, right? So let's go to the board and let's start refreshed, right? Everything that we talked was about sequence. Well, not really. Everything that we talked was differential equations, right? And we didn't really talk about sequence. But today is different. So sequence. I think I gave you why you have to learn this thing, right? Sequence and series. These two concepts are really, you know, like it's kind of best friend of calculus. It's kind of a basic stone of calculus. Now, last time I gave you a definition, right? So what I'm going to do today is a lot of definition. That's why I came up with this paper, right? A lot of definition and some theorems. And some examples. Examples using these things. This is kind of weird, right? Let me rewrite that. Examples, yes. So let's do that, right? So first definition that I want to talk about is about whether we have a limit. When do we say it has a limit, right? Limit and, you know, sequence. Limit and sequence. All right, I don't have to look at this. So I don't think I have to look at it. So definition. All right, a sequence. Notation AN, right, has a limit L, writing, limit n goes to infinity, AN is L. I mean, it's not that hard, right? It's not really hard at all. I am just giving you, if we write this thing, we are saying a sequence AN has a limit L. Now, this is the thing. Mathematically, I mean, intuitively, this makes sense, right? But you have to understand how to read this thing. Well, this is the basic stuff. That's why you feel so ease, right? You're feeling at ease. But if you go further and further, and if you see some, like, you know, harder concept, then you would say, first we need to memorize definition. But this isn't the thing that you have to memorize, right? But here's the thing. If limit exists, we say the sequence AN converges to L. If the limit doesn't exist, does not exist, AN sequence diverges. So this is the definition. Now, as you could see, what is converging? What is diverging? It means that if the limit exists, right? If the limit exists, the sequence actually converges to a number that we're looking for, L. But if the limit doesn't exist, AN really, you know, AN doesn't really exist or diverges. It kind of blows up, right? But last time, right? Last time, we've been talking about another definition, right? A sequence AN has a limit L, right? And writing this is exactly same. Until, so if there is epsilon, which is greater than, epsilon is a number, which is greater than 0, then there exists, then this means there exist. This means a mathematical notation. This means there exists a number n such that, this is such that, what is it? Oops, oh, yeah. If n is greater than n, like the number that infinity, so, and choose a number which is greater than a certain number that we do know, like a capital N, then an minus L is smaller than epsilon. Now, what does this mean? No one knows, right? It's so hard, and I am going to show you what this means, like geometrically, right? We have two cases. I mean, we have two illustrations, but I'm going to choose one illustration. I'm not going to use x and y axis. I'm going to use one particular, just one axis. Now, suppose we could express any of this thing in terms of points, right? Sequence is just a jumble of points, right? Suppose that this is A1, suppose this is A2, suppose this is A3, suppose this is A4. I didn't say I have to go, like chronologically. I can choose any point. So sequence is just like permutation between those like numbers, right? A3, and this is A5, and let's say A6. Now suppose that we choose this n. Are you with me? Oh well, this is an n. This is L. Right? A number that we are looking for. Any converging number that we're looking for. Well, L. Then this bracket means, mathematically, this bracket means we're choosing an interval. Now, this is a two-dimensional, right? So it's hard for you to see why this is so true, right? Whenever you think about the limit, we're choosing a ball of something. We're choosing a ball of something and see whether a value actually converges into this point. Now, what this means is that L minus epsilon is this first bracket. So this is L minus epsilon, and this is L plus epsilon. And what it means that for this interval, there exists some value a n plus n minus 1, a n plus 1. There exists a value. There is always all terms of sequences inside it. Whenever you choose, however small this is, however small epsilon it is, however, even though you choose a point, that point becomes an of something. So do you understand geometrically? Not really, right? So something like this. A better illustration of this, like, the definition itself is something like, well, suppose that this is a line, and 1 and 2, right? You choose any interval, smallest interval. Now, we want to know whether the number itself converges, right? The number itself has a boundary of something. Now, to come to think about it, however small distance you choose, there exists always a number, right? However small you choose, there is a number, right? However you make smaller than that interval, you can find a smaller number than that. And that's the meaning of sequence, when the limit exists, right? Suppose that, you are kind of like choosing a number, like you are jumping around from those numbers and finding a pattern of those things. And as soon as you find an interval, there always exists a number that converges into a certain number.